All right, we're up and running here. Gonna do 10 problems together. You got a handout, you know what problems are coming your way. And when you first come into class tomorrow, we will tackle the exponential problems that we covered in class today and how to put them in logarithmic form, as well as these 10 problems. Gonna send you right to the board and give you a good 45 minutes of trying to practice those problems. And then we'll continue to add some new material. And the 10 linear problems, theoretically, you already know from your Algebra 1 class. Been around long enough to know that probably not going to see that understanding, unfortunately, because when you come out of this class and you have to do these 10 problems at the next level, I'm guaranteeing you'll know how to do them. That's a promise I'm making to you. All right, so here's some elementary school math. You take a moment here, we're just going to set up some important things to see so that the process makes a little more sense to you. All right, so 4 halves times 6, you might have done it as 4 times 6 is 24, and then divided by 2, which happens to equal 12. That's one way. You could have multiplied, then divided. You could have divided 2 into 4, which gets you 2 times 6 equals 12. Could have done it that way. And the most important way is actually this one, where we divide 2 into 6 to get 3, and then 3 times 4 is 12. Now, of these 3 problems, that might have been the one that you didn't try. All right, but when it comes to working with linear functions and quadratic functions and absolute values and square root functions and sinusoids and logarithmic and exponential, we're going to highlight that. Okay, so this course is based on 2 numbers, and we'll see if we can develop those 2 numbers as we go along. All right, so x values, x in, I guess, in Arabic means something. The word something is written, I don't know, a nice way they write x, and I can't do it, but that's what that variable, that's where it came from. Okay, and that's what we do. We use numbers, right? And then we get numbers out, and those numbers we get out, we refer to as the y values. And there's a lot of numbers I can use here. Some of them are easier than others because we're going to add 4, right? And I don't know if you can tell me what 4 plus 7.892835218 is. Okay, I'm going to hide it now. So what's your answer? Okay, but if I just say add 4 plus 7, boy, I can hide the answer. I'll bet you already got your answer without too much work. All right, so it's nice if we can make a nice round number out of this multiplication. So you can pause the video for a second and ask yourself, what numbers am I going to use? Well, I hope you use 0. It's the easiest number to multiply by. And it is a significant aspect, part of this class is to look at the situations where we make products. And those products, we want to make one of the factors of those products 0. In fact, the most famous product might be length times width equals area. Length times width equals area. And somebody figured out if you get rid of the width and make it 0, okay, I'll get rid of the width. Huh, there goes the area. And so much of this discipline is about rectangles that we want to start talking about those from the get-go. All right, so what's the next number? Well, based on what we did over there, I think I'm going to pick numbers like 7 and 14 and 21 and 28. Why am I going to pick numbers like that? Well, I hope you can see why. They're multiples of 7. And of course, 0 kicks us off. And yes, I am being discriminatory. -7, -14, -21, -28. But you know, negative numbers probably came at us historically after the positive ones, right? Somebody probably went on a cave wall. They didn't go, I don't think so. All right. So linear functions. Here's the one way Well, here's the way linear functions come at you in an Algebra 1 textbook. mx plus b, y minus y1 equals y2 minus y1 over x2 minus x1, x minus x1, and ax plus by equals c. Those are the three that are the major, right? I don't like any of those for starters. I like y equals ax minus h plus k form. And that's to the first power. We're going to learn what's it happen when we put it to the second and the third and so on and so forth. So we're going to make a template here. All right. And we're going to look at trying to find some numbers. Let's start with 5/7 again. Let's do x minus 3 plus 4. Notice I made the parentheses a little bit harder. But again, pause the video and think, hey, what's going to be user-friendly here? What are the numbers so we don't have to work so hard? Right? If we think about it hard, and we put some effort into thinking about it so that later on, it's not taking any effort to do. Well, that's what you do in most things, certainly what you do in sports, right? You learn to dribble and do a layup. When you first tried, probably wasn't easy, nor was tying your shoes. But repetition's your friend, right? So here's your first rep. Pause the video and see if you can give me a couple of X's here that are friendly. First one, and you're pausing, I'm just going to continue. First one is this one, 3. Because what happens when we multiply by 3? Oh, we get 0 times something, gets us 4. The next number, pause the video and think about it. I hope you're saying 10, right? Because when you put 10 in, looks like you get 7. Oh, and 7 goes into 7 once. And 1 times 5 is 5, plus 4 is 9. Okay, you're pausing the video. Can you think of another number? I think we want 14, don't we? I guess 17 minus 3 gives us 14. 7 goes into 14, 2 times 5 is 10, plus 4. Did I make a mistake here somewhere? Going up by 5, 7. Oh, I forgot to write 17, right? Yeah, so 14, 2 times 5 is 10, plus 4 is 14. Yeah. And in this class, I hope you don't just do that. I hope you look at it. So take a look at it. I coached soccer for about 50 years. And I always had a no-talk practice, at least once or twice a season. And they were the most productive practices we ever had, right? No talk. Because you got to learn to kind of reflect. I know this is a language, but it's different from, the language we're using right now to communicate. Because there are often times when you have to go, what's going on there? And it won't immediately come to you, but you've got to keep doing it until you go, oh. And we're starting that. We're starting that conversation right here. And we'll continue that conversation over here. Because now I'm going to give you a couple of these values and see if you can write the equation. All right, and usually at the start, it takes students, 3 or 4 minutes to do this. And after a month, it's a 10-second problem. At least that's what I've seen over the years. And I doubt you're any different. All right, so let's put it in tabular form. Let's start with -4. All right, well, where's that going to go? In the y equals. I know I'm putting the y on this side. Well, I think it's going to go right here with a statement like x plus 4, because we're going to multiply times something, yeah. And what's the easiest thing to multiply by? 0. So we want to make -4 into a 0. Watch. It's magic. -4. Whoa, it's 0. And 0 times anything is 0, but I want to get a 7. Guess I made more magic. Of course, there's going to be a change here. And if you were thinking about the last problem, change, 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 I want multiples of what? -4 to 5, multiples of 9. Well, if I'm starting at -4, I think 5 is going to be the next number that I want. Oh, what is 5 plus 4? Oh, it's 9. Is 9 plus 7 equal to -3? I don't think so. I don't think a change of 9 works. Let's get rid of it. Gone. Now I've created the number 1. And I want that to equal -3. Well, how do you get from 7 to -3? You go down 10. Oh, this is nice. I'll put 23 in, see if I get -23. Oh, let's put 23 in. Let's see if I get -23. Well, 23 plus 4 is 27. I think 9 goes into 27 nicely. I think it goes 3 times. And I know what 3 times -10 is. It's -30. -30 plus 7. My God, I can get some numbers quickly. All right, so can we name 4 points? You're pausing the video, right? Every time you pause the video, when I start working on a problem, see if you can, try. First stage of learning is following. Hope you're following. And then when we practice in class, next step is to do it yourself. And then if you got a neighbor next to you and your neighbor's struggling, then the third stage is to explain it. At least that's what we're going to try to do in this class. It's going to be mostly workshop. We're going to have to talk, Emmett and Mark, well, Mr. Yates and Mr. Flynn. We're doing this together and we're trying to stay together, and so classes can help each other. I'll be doing math help on Tuesday nights from 7:30 to 9. Every Tuesday night, you come in and get the reps, because repetition is the key to success in this class. Your effort is going to be directly correlated to how well you do. And if you think you can wait till near the end of marking period, midterm, and the end of the term, you're going to find out that you wish you hadn't done it that way. If you just keep up with it, and just keep looking at these problems each day, lights are going to go on at some point. You'll do fine. All right, so can you name 4 points? Well, what do I want here? I want this parentheses to be 0, 7, 14, 21. Those are the numbers I want. So it looks like I got to put a -2 there. To get 7, I've got to put a 5. Well, it looks like I'm jumping by 7, yes? All right, then 12 and 19. And if I do that, the first time I get a 4, I pay, 0 times anything. And then 7 goes into 7, 1. 3 plus 4 is 7. It looks like I went up by what? 3. Boy, I wonder why, because I'm multiplying friendly numbers, 0, 1, 2, and 3 by 3. I'm making the numbers 0, 1, 2, 3, right? Because when I put 14 in, I want to make the number 14. So when I put 12 in, sorry, that's what I said over here. 12 plus 2 is 14. How many times does 7 go into 14? Twice, which means I jump the number 3 2 times, should get 10. Right? 3 plus 3 is 6 plus, lost track of, plus 4 is 10. And a 19 should get me, what, up 3, 13? Let's see if a 13 comes out from a 19. And this was 19 plus 2. Oh yeah, 19 plus 2 is 21. 7 goes into 21. I'm jumping it 3 times. There's 9 plus 10. I don't know what I just said. 7 into 21, 3. Right, because I did that, right? There's your 9 plus 4. There's your change of 9, starting with 4, getting us 13. Good. Lost track of what I was saying for a second, but hopefully you followed that. All right, so let's sketch. How many points is it? Well, you're pausing the video. Remember that now. Got to tell you that at the get-go. How many points does it take to graph the equation of a line? Only 2. Can you find the 2? All right, kind of repeating here, same kind of topic here. Well, I hope you're picking -2. I think it's, did I do the exact same problem? I think I did the exact same problem, right? So can you spot -2 and can you spot 5? And can you put -2 in and see 0 times anything is gonna get us 4? And if you put a 5 in here, can you see the sevens canceling? 3 plus 4 is 7. So all you gotta do is plot those points. Let's call this 1, and let's estimate -2 for it. So that's 1, -1, -2, up 4. It's right about here. We'll call that point A. Right? And I don't want to put A there because this function's going up. Right? Notice I put the 1 there. Linear, one dimension. Algebra comes from geometry. And the next one's 5, 7. So if this is 1, 5 is about here. 7 might be about there. And it looks like I'm going over 7 units and up 3. There's your slope, we call that, which is really a ratio of change. And each function has its own ratio of change from particular places. Planting some seeds here. So it'd be nice if you put some arrows in. All right, so here's a, did I do, I don't know, what, I must have missed a problem here, let's see. The sheet, because it seems like I'm looking at the same problem over here. Number 4. Oh, mx plus b, so I skipped putting something in mx plus b. So I'm out of order here. Okay, go to jail, do not collect $200, whatever it is now. Inflation, I don't know, I probably got to get more when you go around go now, I don't know. So slope intercept form. Okay, and the only reason we're doing this right now is to see if from your elementary school you remember how to multiply a fraction and add and subtract a fraction. All right, so for all numbers, I could have written, that's what an equal sign means, may have written this problem as 3/7 times x, the distribution, which is really 3 times x and then dividing by 7, because we do not know what x is. It's supposed to work for all numbers. But I can tell you what 3 times 2 is. That's 6. And dividing by 7 gives me 6/7. And I know I need a common denominator. So I know it's got to be 7ths, otherwise I can't add those things together. Got to have likeness. Okay. And I hope you can see that 7 times 4 gets you 28. And so this becomes y equals 3/7 x plus 34/7. And so we sketched it over there. And if I recall, we sketched it over there. We had something that looked like that, which means that you're really here at 0. Put 0 and you get 34/7, which is a little bit smaller than 35/7, right? So we're up about 5 units. And we're going to go over 7 and up 3. It's got the same slope, brings us to a new location, which isn't user-friendly. I mean, I can't tell you immediately what that next number is. I can tell you that this is a 7 right here. That's an x value of 7. I can see that. But I got to add 3 to 34/7, which is really, 7's 21/7. 21 and 34 is 55/7. I mean, I can do it, but, that took a little work. I didn't know that till I, did the computation. Whereas -2 gets us 4 and 5 gets us 7. Boy, I can see that. Okay, so this is a whole lot more friendly than this. It's the same line. And this is going to help us down the road. It's going to help us examine some polynomials that are going to aid in our graphing. I don't want to diss it completely, but there's easier ways to do problems sometimes than what's in the books. And that's what we're after. All right, so what do I have here? Okay, a book for your SATs. It's important that you can, recognize this and sketch it. It's point slope, right? And really, it's all about making zeros. What makes zeros? I hope you say -4 or 5. Right, so we can go to -4 or 5. Is it the same problem again? No, it's a different problem. Yeah, because this is decreasing. So we can go to -4 or 5. Let's call that 1. -4 or 5 might be there. We'll call that point A. Right? And I can see that I changed by 3. So -1, go down to -1, 3. Negative 1, 3 might be here. Let's call that B. Negative 1, 3, we'll call that B. And there's my graph. And if you're having trouble with that, don't be afraid to move that minus over to the other side and make it plus. Can I really do that? Let's see. Let's see, 5 plus 3 is 8. Does 3 really equal 8 minus 5? Oh yeah, that's an addition of 5, and an addition of 3 is 8, so addition on the left. Boy, that's subtraction on the right. That could come in usefully. I bet it's gonna. Well, we're on that topic. I think 5 times 2 is 10. I think 2 is 10 divided by 5. Wow. Multiplication by 5 on the left is the same as dividing by 5 on the right. Ooh. Wow. And 3x plus 4x equals 7x. Is that really true? Let's try it with a number. How about the number 10? Randomly. 30 plus 40, yeah, 3 times 10 is 30, 4 times 10 is 40, and 7 times 10 is 70. Hey, it seems to work for that. And does 3x equals 7x minus 4x? Does 30 equals 70 minus 40? It sure seems to. So it looks like addition of a term on the left is the same as subtraction of that term on the right. Well, that could be helpful, especially when we solve equations. So you have to figure out if your instructor allows you to do this or not, but I'm letting my class do it. Well, I guess we got to talk about order of operations. Please pardon my dear Aunt Sally. Please pardon my dear Aunt Sally. No, I'm not into pardoning her at all. Okay, math has evolved from more difficult operations, easier operations to more difficult operations. And I think I already told you what I think the first operation was. Yeah, I think somebody went in a cave and went, and then I think somebody did, and then we eventually got 1 plus 1 is 2 written down somewhere. All right, and then for somebody probably did 1 is equal to 2 minus 1, figured out addition becomes subtraction on the other side. Then I'm guessing multiplication, division, powers and roots, exponents and logs, integration, differentiation, right? Inverse operations, operations and inverse operations. All right, and multiplication and division, they're both the same. But it doesn't matter what order you do those in. But generally speaking, we do parentheses. We'll give dear Aunt Sally a little credit. Do parentheses first, then do the hardest stuff first after that. All right, so how would you do 7 minus 2 times 4 minus 8 squared? How would you do that? Well, I hope you would do 7 minus 2 times negative 4 squared. I hope you would do 7 minus 2 times 16. And I hope you would do 7 minus 32 and get minus 25. And I hope you did that in pre-algebra. If not, you'll get plenty of practice here. But how does that help us? Well, let's look at it. This equals negative 25. And let's see if we can get the number 4 to work here. And solve this equation. And this is not a linear equation, this is a quadratic. Well, let's see if we can just use some inverse operations. Well, when we evaluate to get negative 25, we got to do some hard work. Going backwards, let's take the easy route. Addition of 7 is the same as subtraction on the other side. Multiplication by negative 2 is the same as division by negative 2 on this side. Squaring is the same as taking a square root, and I'm sure you didn't remember the plus minus, but it's plus minus 4. And subtraction of 8 is addition of 8. Well, there's our negative 4 plus 8, right? And that's equal to positive 4. So remember, that's what we were looking for. But there was also another number there, 4 plus 8, which is 12. That also works, right? Because 4 squared 16 and negative 4 squared 16. I am ranting here. So let's just get those last linear problems done. So how am I going to solve this problem? I'm going to add 6 to the other side. That's 1. And I don't want to see plus 6, for God's sakes. We're going to make some gains here, and we got to make some steps. So plus 6. Division by 7, multiplication by 7. That's easy to get rid of. And multiplication by negative 3, dividing by negative 3, and put the negative sign in the numerator. Hopefully you'll learn that in your Algebra 1 class. All right, now what were you looking at? Let's go back to the original. What is minus 3/7 x minus 6? I already forgot what we had. 1, 7 minus 7/3. That's right. That was our x value. Okay. Do you recognize that? You recognize it as mx plus b? It's equation of a line. And I'm at negative 6. If I put a 0 in, hope you can see multiplication. That's multiplication right now. And the easiest number to multiply by is 0. 0 gets you negative 6, and I'm going down at 3 to 7. Okay, I'm going down at a 3 to 7 ratio. All right, and I want to hit a height of negative 5. Well, negative 5 is over here, right? That's a height of negative 6. Negative 5 is above it, and we're looking for that x value. Does it seem like minus 2 1/3? Yeah, it's reasonable. Reasonable that if I did a table of values and I put negative 7/3 into this problem, well, that's not too bad. Let's actually put it in there. Because I don't know, I'm seeing some cancellation. Right? And minus 3 divided by 3 is minus 1. Ooh, I forgot the minus. Yeah, otherwise it wouldn't have been negative 5. A negative times a negative is a positive, right? And so really, I've got a reciprocal here. And what is 1 minus 6? Negative 5. All right, so the last 2 problems I'm just going to do quickly because the video is taking too long. All right, so I don't like dividing by a negative. So I'm going to show you an extra step. I hope you can do this in your head. Subtraction becomes addition. Addition becomes subtraction, right? So I'm hoping that you don't need to make that statement. You can do 4 plus 2 is 6x in your head. Take 14 away from 5 and get negative 9. And so this is negative 9/6. We're going to learn how to do that. And these are 2 linear functions. Y intersect of 5 down 4 over 1, ratio like that. This one is 14. Positive 14 is way up here. I'm higher up here somewhere. That's 5. It's up there. And I'm going up 2 over 1. All right, so I get this intersection, some negative number, not too big. Oh, there it is. Minus 1.5. Okay, so that's minus 1.5. And that's where those lines intersect. Okay, planting some seeds here. Remember, do this for 4 days and worry about it 4 days from now. Not now. All right, so how would I handle this? Well, I know what undoes division by 7 and 2. 14. We'll have to take more time with this in class to show you why it works. But I can do 7 into 14, which is 2. So that gives me minus 6x. Minus 6 times 14 is minus 84, I think. Hope I didn't make a mistake. 2 goes into 14. 7 times 5x, 35x. And 14 times 3 is 42. I'm going to bring the minus 6 to this side. 41x. I didn't write that too well, but I'm going to take 42 away. So that's 126, I think. I'm going to divide by 2 here just to make life easy for me. Minus 63 equals, oh no, that's 41, excuse me. So I'm just going to do, yeah, I should. I almost didn't read this properly. All right, so my answer is minus 126 over 41, which is approximately negative 3. That's where those graphs would intersect. All right, 5x minus 4y equals 40. 5x is a product. 4y is a product. And I think I've already told you earlier in the video, make products equal 0. So if you pick the 0 for x, like covering it up, oh, that's negative 10. That's a place on a graph, 0, negative 10, we'll put it there. I know this function is going to be going up. Because as this gets bigger, this has to get bigger to remain constant. That's a product. If you put a 0 in, it's covering it up. 5 goes into 48. So where's 8, 0 might be about there. Right, there's your line. And that's called standard form. All right, we'll have no trouble with that. 4 days of practice. That should be a piece of cake. Perpendicular, let me just show you the relationship of perpendicular. That's all I want to do right now. Let's go over to 2 marker lengths and up 1. All right, so that's over 2 up 1. All right, perpendicular, 90 degrees. 90 degrees. That's about 90 degrees, I think. All right, that's my best guess for 90 degrees. Let's go over 1 marker. Let's see if we can go down 2. Oh, I hit it pretty good. Okay, so the perpendicular slope is the one decreasing, and the one decreasing is decreasing at a change in y, change in x. The original one, change in y, change in x. Do you see a relationship between these perpendiculars? Yeah, one is positive, one is negative, and then one is reciprocated, flipped. All right, so if we can just get into y equals mx plus b form, then we can get that m, which is one of these numbers. And all we got to do is change the sign and then have it go through a particular point. I didn't even give a point here. I don't know. Let's say we want it to go through 5, 3. From our earlier work, I hope you would write x minus 5 plus 3. Maybe not yet. Right? This might be going right through your head and you might be already in tears. Don't worry about it. We're going to keep doing this every day until it's a piece of cake. I like cake. All right, so let's get an mx plus b here. And obviously the m is what we're after, not the b. So that constant doesn't matter. I don't like dividing by negatives. So I'll just move that -3 over. The other side is +3. And now I can see my m. 7 divided by 3, x equals y. That's the original slope. So what's the perpendicular slope? -3/7, and there's your perpendicular. All right, and so when you come into class tomorrow, if you've watched this, I'm giving you 10 new problems. Maybe even we'll do the same 10. Just see if we can get it to come back in your memory, because it's all about long-term memory. That's why we're not doing 20 of these in a row and then go to something else for 20 in a row. Because 20 days from now, you're not working on any of those problems and it's disappearing, just like it probably has right now from your Algebra 1 to this course. All right, so we're up and running, and put a smile on your face and don't worry about how you're doing at the moment.